Okay, so today we're going to be looking at different ways that you can use your graphics calculator to do matrix applications for you. So really this comes down to two different ways that you can input them into your calculator, both give you the same answer. It's more about how many times you want to use that answer. So if I go over here, this is my calculator, I'm just in the normal run matrix. If I go matrix vector, here we've got our matrix. If I wanted to change it to vector mode, all I have to do is press this button down there. So I'm going to input something as matrix A. So these are the calculations we want to do. So matrix A, execute, it's going to have a 2 by 2 order. Come on, baby. All right, and so now I've got a space where I can enter in all of the values that are in those cells. So I'm going to input the values in from to the side there. Execute, okay, and now that one has been saved in as matrix A. So I'm going to exit out of there, and then I'm going to go to matrix B. Now, in matrix B, I'm going to do the same thing. I'm going to make it a 2 by 2 matrix, which gives me this. Input all of the numbers into the cells again. And there we have 2 matrices that have been assigned. Just make sure that you note down what letter is what. I've assigned it the same as over here. So this is what I would normally do if I was going to be performing multiple different things with my graphics calculator. If I was just going to do 1 or 2, I'd do it a different way, which I'll talk about in a second. So I'm going to exit out of here, go back to my run matrix. Now, when I go option, I get this is another option that I can select. So I'm going to go option math vector. Then if I press math or mat, which is matrix, and then alpha A, that will bring up the matrix of A for me. So if I want to perform that first operation, it's matrix A minus matrix B. Execute, and that's the answer that I would get for matrix A minus matrix B. If I want to put a scalar in front of it, and this is the answer to the question that we're doing, matrix A is multiplied by 2. So I'm going to put a 2 in front of it, which will multiply matrix A by 2 by that scalar and subtract matrix B. So that's how I can perform the first one. That's the answer to the first one. Now, the other things that you might want to do actually, here we go. So matrix alpha A. Now, I get other things that I can do. Now, these instructions will go at the front. So I'm going to put determinant of matrix A, execute, and it will tell me what the determinant is. Remember, if your determinant is equal to 0, it means that your matrix is singular. If I want to get an identity matrix, identity, see what happens here. Matrix A, nah. Oh well, lucky try. There's a lot of different calculations that you can perform just using some of those ones that are in there. It's just about going in and having a bit of a practice with them. Okay, so now if I look at performing the operations below here, I'm not going to bother changing my matrices. I'm just going to use them as they are. So matrix A to the power of 4. Boom, now I've got my matrix A to the power of 4. If I wanted to do matrix A times matrix B, I'd just input it the same way that it's written there. I'm going to delete that. So times option matrix mat alpha B. That's all going to be in the bracket to the power of 2. I need the bracket at the front as well. Execute, there we go. Now, that is what I would do if I was doing something over and over again with a matrix. If I just wanted to input it as, I'm just going to be knocking about with my matrices and I want to use them once, so I just want to see what I'm inputting on the screen. We're not going to go into this section. We're going to go to, let's see, option, give me a second to click around to find it. Normally I use the other one straight away. So if I go math maybe. Yep, matrix vector. And then here I can select what kind of one I want. Now, I'm going to show you how to use your calculator to do Gaussian elimination next. So I'm going to choose an M by N matrix, and I'm going to put in M is the number of equations. There would be 3, but because I'm going to do a Gaussian elimination question with you, we're going to put in 4 for N. Execute. So let me just write a question to the side over here that we would be solving. So let's say that I've got a system of equations. Now, I'm not going to write out the whole question, but, you know, normally there would be x's and y's. So if this is my augmented matrix, let's go 3, 2, 7 / 8, 1, 4, 5, 2, 6, 9, 7, 5. So this is my augmented matrix. I'm going to put in the 3, 2, 7, and I'm going to put my value matrix in there as well. So when you're inputting this for Gaussian elimination, it all goes in one big clump. Okay, and there we have it. So that is my augmented matrix that I would be entering in. Now, the next thing that I want to do for this is I want to get this in something that we call reduced row echelon. Now, this is what we get as our output for our Gaussian elimination. It is really just a fancy way of saying I want to get the identity matrix, and then I want to have my value matrix to the side here. So if I go, no, I'm going to go back to the very start. Oh, well, that's a pain. All right, so if I go back to the very start, I'm going to do option matrix vector like we did before, and then if I click across here, I'll get more options. So reduced row echelon is this one here, RF. Row echelon is something different, and we'll talk about that next. So let's just put my values back in. How painful. On the right side, this gives you some time to follow along, huh? Take some notes. Good for you, good for us. Okay, execute that bad boy. Oh, boom, there you go. You've got your answers about what our reduced row echelon form would look like. So here you can see that that is our identity matrix. Here's our answers there. Now, the other thing that I wanted to show you is you could also get this in just row echelon form. So that is going to give me 1s along the diagonals, 0s underneath, and then up here I'll still have numbers. Now the purpose of this is that once you get this, like that, there's my answers, like I said, 1s there, numbers here, numbers there. I can use back substitution to work everything else out, and it works out a lot easier than trying to use simultaneous equations from the very beginning. So the way that I would go back and input this to find out my answer is, you know, this would be a system with x, y, z. If this is my final answer, then I know that z is equal to negative 32 over 3, which means that I also know that when I'm trying to solve for what y is equal to, I can input it into this row here because I'll have 1y plus 13 over 14z will be equal to negative 1 over 14. And I know that this is equal to this, so I can replace that. Which means that now I can take this to the other side to work out what y is. If I was doing this, you know, and I could use my calculator to get to this form, you better believe that I would not be bothered doing this, and I would chuck it straight in reduced row echelon form unless it asks you specifically to do it the other way.